Well, good morning, everybody, and a warm welcome to the STEMPOINT East STEM Inspiration Week today. Lovely to see so many of you with us. Please do make sure that you keep your cameras and your microphones off, just so that we can minimize background noise. We will be using the chat function as well, so teachers do keep an eye on that for any information we need, or if you would like to ask any questions throughout the presentation as well. So let me just hand over to Halisha Patel from GSK, who will be presenting this morning. Over to you, Halisha.
Thanks very much. Hi, everyone. Thank you very much for inviting me and signing on to this presentation today. Uh, this session is going to be a little bit about manufacturing engineering, my role, GSK, for the company that I work for, and you should have a worksheet that's downloadable, and it's just a little exercise. If you don't, we'll have a slide at the end. So it's a little bit of a fun exercise we can do at the end just to learn a little as well. Vanessa, would you mind sharing the presentation for me? That is great. If we go on to the next slide, please. That's the one. So just again, a little bit about the session. So we're going to talk about netiquette or net etiquette. So just how we can expect this session to run. Like I said, a little bit about me, introduction to manufacturing engineering, a couple of techniques that we use, and a practical exercise. If you go on to the next slide, please. So just some tips about, we're in this virtual world and everything's different. Some top tips from me would be present. So that doesn't mean give yourself a gift. It means listen to the session, engage, ask questions. Don't be distracted by mobile phones. I know it's tempting, we all do it, but for this session, it would be really great if you could just stay engaged. Be curious, so please use the chat function to ask any questions. I have it open so I can see if anyone has anything to say. And there'll be moments to pause in the presentation itself to ask questions. And again, be heard. So, be heard. So if you have any problems or anything throughout the session, please let us know. We'll see if we can help. Thanks. Next slide. So a little bit about me. So my name's Halisha Patel. I did A-levels in chemistry, physics and maths. So I always had an interest in the sciences and maths, but I didn't really know what I wanted as a career. I knew I liked the science and maths, but there wasn't really a lot of options for a girl. It was like, do you become a doctor and go into medicine? Could you work in a lab? And neither of those really sounded like me. So I did one of these like career tests, and it gives you an idea of what you might like. And engineering came out, and it wasn't till I actually went to university that my lecturer recommended that I did a manufacturing engineering degree. Because that's where my natural interests lie without me even realizing it. So yeah, that was 4 years there, which was really great. So my current role is that I'm a manufacturing technologist at GSK, which is a big scary word, which actually means what I do is I support the production line. So at GSK where I work, we make tablets, so for HIV and cancer tablets. So I support the production line in that, making their processes more efficient and reducing waste. We'll talk a little bit more about what it means to be a manufacturing technologist later. So a little bit about GSK. Some of you might recognize the logo and some of our products there. We are a global healthcare company that work with pharmaceuticals, vaccines, and consumer healthcare. So our vaccines probably the biggest thing in the news at the moment. You might be aware of some disease that's going around. Yeah. So we're currently working on the COVID vaccine and hoping to support the production of those next year. Consumer healthcare, so you can see our Sensodyne, and there's a lot of things there. I work in the pharmaceutical area, so we talked about tablets. So yeah, I work in the tablet manufacture. We've also got respiratory products, so you might be aware of the blue Ventolins. They're quite popular. Some of you might even have them. So they're GSK as well. So we're a pretty big company, not just in the UK, but globally. I'll just take a pause there. Does anybody have any questions about GSK or anything I've said that you've gone, I don't know what that is? We can take 2 questions now if you like.
I can ask one, Halisha. Are you how much are you all involved in the COVID vaccine? Because I'm sure people are wondering that as well, or will you cover that a bit later on?
Yeah, of course. So me personally, not as much. I work in the pharmaceutical industry, but with the vaccine, so GSK there's a testing site in Cambridge, so we're doing a lot of the research and development in there. But what GSK has promised is the actual manufacture of the vaccine, so the vials, the needles, all of that, and how we actually go from something in the labs and then mass production into basically making sure that everyone gets a vaccine on time. So I think we've promised like 1 billion vaccines for next year, which currently we make 800 million. So to then promise another billion on top of that, it's the big asking. So most of our um, processes at the moment is about mass production of those vaccines. Yeah.
Thank you. That's really, really interesting to hear.
How much does it cost to make a vaccine? That is a good question. One that I don't know, but I can tell you that for every one product that goes to market, there's 500,000 tests and um, like candidates, we call them. So they're like things that we try to see if they work as a vaccine. So if you think every time that you get a vaccine that works, what 500,000 have gone through testing before we've got to the one that works. So it is absolutely billions that goes into it. Yeah, that's a great question. Thank you. Okay, we'll move on from there. Keep an eye on the time. So some preconceptions about engineering. I don't know a lot of your backgrounds, obviously, if you've ever been to a manufacturing site or worked in a factory, but what is engineering? I hear this word, I don't know what it means. So people think engineering, it must always be dirty. If you can click on the next slide, yeah. So here's some pictures of us actually at work. So because I work in pharmaceuticals, actually our environment is incredibly clean. We actually work in clean rooms. We wear mob caps and overalls and things because it's all about contamination and the risks that humans bring to that. So if you imagine if you were taking some medicines and you like opened your bottle and you suddenly saw hair, you're going to be pretty concerned of what's happened to that. So we work in an incredibly clean environment. So engineering is not always dirty. Go to the next slide, please. Engineering, oh, it must be repetitive work that's on a computer. It must be really boring. It's not, in fact. I spend most of my day on my feet going to the lines and looking at what's happening. So these are some pictures of some projects that I've been working on. So the picture in the top left is a wave tank, and it's basically used for like testing flood defense systems. So it's a massive one in Sheffield University that is the size of like 3 swimming pools. It's huge. It's wicked. Um, that bottom video that you've got shown there, that is a 3D printer. So I don't know if any of you have these in your schools, but they're like desktop printers that you can literally print anything. So this was a project to improve the sustainability of toys that kids have. So it was trying to reduce the amount of plastic waste and things that we use and seeing if there was a sustainable way of producing that and then also customizing it. And then that one in the in the right was actually my final piece. As you can see, it's very technical. It basically is a switch that we then use to lock containers that kept um, like important assets for the government that they wanted to have a smart switch that basically anyone could activate using their phone. Only if they had the correct like passcodes and things like that. And that is basically a massive project that got broken down into a simple circuit board. Um, so engineering, it's super practical, and it will yeah, you're always using your hands and always on your feet and going and looking at things and understanding the problem. It's definitely not just working at a computer. Next slide, please. It's not very creative. So I think the general understanding is that it's people who sit at computers, like maybe not very talkative, kind of keep themselves, and it's really not like that. It's for it, there's always really creative solutions. So this video on the left is one of our university projects where we had to create a Lego sorting machine that could sort colored balls. Probably not that practical, but if you imagine it's like sorting products out and putting them into one area, it's a similar system that Amazon uses to sort out like different products. It can be based off color or size, for example. And the video on the right is a water bottle rocket launcher. Now, this is like one of the silliest things that we did, but it taught you a lot about the design process and what it means to be an engineer. It's kind of like, what happens if you add another fin? What if you change the nose cone design? What if you made it look like Thunderbird 1? Who knows? It's kind of all there. So yeah, it's definitely not something that has to be boring or repetitive. Yeah. Next slide, please. And finally, so it's not just for the boys, surprisingly. So that's my team there. That's how we normally look when we're in production. As you can see, there's 3 girls there and 3 guys. We're a really diverse team, and that's something I really enjoy because everyone brings different perspectives and different opinions. You don't have to be a boy to do it. You can be anyone, just as long as you have like a curious mind, and you have an interest in how things work and how things are made. That's exactly how it is. Yeah. And they go, so lots of them have science backgrounds. They don't necessarily have engineering backgrounds, but you can still work in a manufacturing environment. Yeah. Go next slide. So engineering is literally everywhere. If you think about where you're sat right now, probably you're sat at tables and chairs. Most of you, they would have all been mass produced. You've got transport, you have sports engineering, so down to the trainers that run as well, down to the tennis rackets that people use. You've got flood defense systems, so if you remember the floods in Venice, the engineering solution that came from that, about how to stop it from happening again, it's all engineering. Really important is the environment and the sustainability factor, so using solar energy, using wind power, how can we harness renewable energy sources and make the most out of them. Food packaging is a huge industry. If you think about Coca-Cola, we got to go visit there. Their bottling line is just incredible, the speed that they can produce. I think it's like 100 bottles of 100 bottles of Coke come off a line every second on one line. It's pretty impressive engineering. And then, of course, there's the technology side. So your phones, your other types of tablets, your computers, all of that. It's all changing so quickly, and engineering is literally everywhere. Yeah. So just at this point, can I pause for any questions? Anyone brave enough to put a question on the chat? Again, we can take 2. I've just seen your message, Dawn. Sorry, we're not going to start again. We're just going to carry on, but we've not missed too much. That's all right.
Alicia, it's so interesting you're saying about that girls can do engineering as well, and I think that's such an important point for schools, and I'm sure that I'm sure that's really encouraging and inspiring for everybody as well. It's just fascinating how you're right that engineering comes into everything, literally everything we use and sit on, and it's all been created by people, so and very creative as well. So I really appreciate you making that point. That's really inspiring for the schools to hear.
That's all right. I think for me, what was surprising is how much it impacts our life. So I'd never considered like the engineering of drugs, for example. I thought you had to be like a chemist to work in that sort of area. But it's manufacturing engineers is what people need, and there's a huge gap in the market at the moment for engineers, and particularly for manufacturing engineers. So yeah, here's some questions. Did you face any challenges as a girl going into engineering? Yeah, so I would say at school, I went to an all-girls school, so engineering wasn't something that they knew about. The person who actually like wrote my reference for university didn't know what engineering was, so I had to tell her. So that was a challenge. At university, so I was the only girl in my group. So there was in my year group, so there was 15 of us, and usually there's not a lot of us. I didn't really see it as a problem. I saw it as an opportunity. They start off when you have to like make groups at uni. First of all, they all want to go together, and then suddenly they realize that you're pretty good and they want you in their group. And then at work, it's very different. So I work in a male dominated area. Um, and it's challenging because sometimes you're undermined. Sometimes people don't really know how to deal with a young woman and they don't know how to talk to you. But you learn how to deal with them and you just stay resilient. The work's so good, I would never change from that. Where are we going? What is the difference between a car mechanic and a car engineer? Great question. So a mechanic is someone who will get their hands dirty and will fix the car there and then. They'll probably run diagnosis and say you have flat tire, they'll change the tire for you. An engineer will be the ones that will actually design the tire itself. So they'll look at kind of how long is the year life of the tire? Do we want it to last a year? Do we want to last 10 years? What materials do we make it of? What shaping should it have? What should the tread be? How thick should the tread be? That's the difference between an engineer and a technician. I hope that answers your question, and we're going to go into it a little bit more as well. How much money on average? Good question. So engineering is wicked. We get a lot of money. No joke. So graduates on average get 20, I think it's 26 or 27,000 as a starting salary. If you compare that to other jobs, that's pretty good. Once you get your chartership, you can be up to like 40 or 50k. It's yeah, if you want to do it for that, it's a good job to go into. Yeah, and like I said, we're high in demand, so that's always good too. Right, thanks for the questions. They're really great. I like having a discussion. Okay, so specifically, what is manufacturing engineer? I keep saying this word, but still not getting it. Let's break it down. Manufacturing, it's about making of goods by hand or machine. It's taking raw materials to your finished product. That is the whole point of manufacturing. It's physically making something. You want to click again, please? Thank you. What is engineering? So the engineer is basically, it's this woman, Lego woman here. She is the person who stands at the line with a clipboard, with a pencil, and writes down observations of what is happening. They look at process design, look at improvements, looking at making it sustainable, making it efficient, reducing waste, etc. It is using the experience and the knowledge and the theoretical knowledge that you have, and then looking at the problem and saying, right, how can we make this faster? How can we make this easier? So it's not these little Lego people in the pictures who are actually running the machines, they're operators. What an engineer does is they will look at those behaviors and look at those interactions and think, how can I make their life easier? How can I get this product out faster to help people? So I think that kind of helps with your what's the difference between a technician and a mechanic and a car engineer. So an engineer is more about the design process and how can we make things faster. Does that make sense? Okay, so now this is a little bit of learning because I thought, why not? Why don't we teach something? Because I always find this really interesting. So one of the techniques we used is called SMED, single minute exchange of dies, which really doesn't mean a lot, but basically it's the principle of improving changeover processes. So imagine you are baking a cake. You're going to bake a chocolate cake, and then the next one you're going to make a vanilla sponge. So when you finish making your chocolate cake, you've then got to do all of your cleaning your equipment, cleaning your area and stuff before you can start making the vanilla cake, because otherwise you're going to get contamination. You're going to get chocolate chips in your vanilla cake. It's not good. So what we think about engineering is how can we improve that cleaning process to make it faster? Can anyone think, maybe we can put these on the chat, why we'd want to reduce the time it takes to set up our processes to run next? See if we can get a couple answers going. To make more in a short time. Boom, very good, exactly. Making both mixes at the same time to add a point of differentiation. Nice, add chocolate. Yeah, definitely. Anyone else? To meet deadlines. Yeah, really important. You want to make sure that you've committed what you've produced, whatever you've committed to your customers. Yeah. Okay, these are some great examples. Can we click the button again, please, Vanessa? Thank you. So why do we want to do this? We want to eliminate waste. Everything in business is about reducing waste, reducing cost, but also in terms of the environment, like we don't need to use more than we actually need. Reduce the time between manufacturing process. So I think that was mentioned as the first point, make more in a short time. It's faster to set up the next process, and it's all about getting it faster to market and to the customers. So if you think about it, if you're the first person to release a new product, you're likely to get more of the market share. So if you're bringing in new things, you want to get that out as fast as possible. And the more you make, the more you get out in a faster period of time, you're going to have a larger share of the market, and your customers are going to be happy because they're going to get their products faster. So that's one principle that we use to help reduce our timings. So let's think about this. Oh, let's do this. Let's do the steps. So what do we have to do in this process? There's 3 easy steps. 1, we're going to remove the waste, take out all the activities that we really don't need to do. 2, we're going to separate the external activities. So anything that can be done outside of this changeover time, we can do that. and it won't impact like our processes. And then 3 is to streamline our activities. So are there any activities that we can do at the same time? So I think someone mentioned like making both mixes at the same time. That's exactly what we can do. So I guess this is pretty theoretical. So let's try and put it into a practical example. So if we can go on the next slide, please. So imagine we are going to create a process map for how to change our bed sheets. This is unfortunately something that we all have to do. And let's use this as an example. So first things first is you're going to create a list of all the activities that you need to do and how long it takes. So Vanessa, if you can keep clicking through that till the end, that's the one. So first thing you've got to do, you've got to take off your pillowcases. You've got to take off the duvet cover, take off the bottom sheet. We're going to fold the sheets, put them all in the dirty laundry, collect the new bedding, put on the bottom sheet, put on pillowcases, put on the duvet cover. It's not rocket science, this, right? It's just a process map of what we do. And it tells you how long it takes for 2 people to carry out this task. We're imagining this is a double bed. So you need 2 people to put that bottom sheet on. It's too difficult otherwise. So this current process takes 32 minutes. So if you click one more time, thank you. So using this technique that we've just learned, can we reduce the time from 32 minutes down by removing the waste, by separating the external activities and streamlining the activities? So if we can click again. So if we look at our process, we can look, why do we need to fold our dirty sheets? We can just put them straight in the wash, like no one's gonna mind. So if we click again, we can eliminate that from our process flow and we take it from 32 minutes down to 27 minutes. Make sense? Now, if we separate the external activities, so can we put the dirty laundry in the basket after we finished, and can we collect the new bedding before we start? If you click again, so you see here, we've separated the activities and we put them outside of our process. Again, not rocket science. We're just saying, can we do activities outside of what we do in the changeover process? And then finally, can we streamline our activities? So can we divide the tasks out for 2 people? So can one person deal with the pillowcases, one person sort out the duvet? You want to click again? So this looks slightly different, but if we follow the first row, so where person 1 is, they're going to take off the pillowcases, they're going to take off the bottom sheet, and they're going to put the pillowcases on. And that's all the activities that they need to do. The second person can get cracking with the duvet cover, taking it off, putting the new one on, and putting on the bottom sheet. Now remember, if it takes one person 5 minutes to do a task, then it's going to take, if it takes 2 people 5 minutes to do a task, it's going to take one person twice the amount of time. It's just basic logic. Imagine if you had a friend helping you, things would go a lot faster. So that is how, very quickly, you can see, if you click one more time, please. Thank you. How we can go from a 32-minute process to a 22-minute process by using those 3 really basic techniques of eliminating waste, eliminating waste, externalizing your activities, and streamlining them. I admit that was incredibly quick and it might not make sense. So I'm going to pause here for any questions. If we'd like to go over that again or anything like that, we have time. Or maybe just some feedback of, yeah, that makes sense, or whoa, what are you on about? It's difficult because I'm not in the room. How much waste does our company produce? You know what? I couldn't give you an answer for that one. That's a really interesting question. So we work off our waste by site. So you have waste that goes off to landfill, waste that goes to incineration, and then waste that's recycled. I really couldn't give you a number. Our class has just joined. What have we missed? You've missed the whole talk. There's nothing else here for you. I'm joking. It's all right. So we've been talking about manufacturing, engineering, things like that. I believe the session's been recorded, so you can watch it back. We were just going, oh, there we go, like that. Okay, so we're going to move on to the exercise. So I appreciate for the class that has just joined and maybe doesn't understand, I'll be happy to talk them through it whilst we do it. Hopefully you all have the worksheets either to hand or you can just view the slide. If we just click 2 times on that. Thank you. So imagine we are now engineers and we work in a we've been given this scenario where we're going to a restaurant and they're saying, oh, it takes us 51 minutes to cook chicken fajitas. We need to get that down because we need to get it out to our customers much faster. So here I have a list of all the tasks that you have to do in this process and how long it takes one person to do it. So using that technique that we've just learned about eliminating waste, externalizing activities and streamlining activities, can you figure out a new process that is less than 51 minutes to create chicken fajitas? So if you have pens and pieces of paper, that would be good. If people don't, you can talk it out within the class. Think about the activities that can be removed, think about the ones that can be externalized and which ones can be streamlined. I'm going to go quiet for a bit. If anyone has any questions, feel free to put them in the chat, and we can talk it out. But we've got about like 10-15 minutes on this, so it'd be really great if everyone can get stuck in.
Thanks, Alicia. And I think if classes do have questions, please do put them in the chat, as you said, and then obviously you'll be able to answer if you get stuck on anything. It might be nice to sort of check in every few minutes just to see how everyone's doing, which we will do as well. So yeah, good luck. It'd be really interesting to see what everyone comes up with.
All right, I'm going to do a quick check-in. Have people identified activities that can be removed? See if you can put them in on the chat, or if we're still working through it, that's also okay. I realize this is quite a workout for the teachers as well. Hope that's okay. Yes, cut the chicken. Could just buy diced chicken. Easy fix. Nice. Pre-cook the chicken. Yeah, I guess you can buy like ready-made cooked chicken. Nice. Warm up the wraps whilst frying the vegetables. Ah, great suggestions. So that warm up the wraps is actually streamlining the activities, doing things simultaneously. So that's good. You're already on step 3. I love it. So have we got any processes that can be externalized? So we talked about kind of pre-cooking the chicken. Is there anything that we can do outside of the actual cooking process that can be done before. Cut up into smaller pieces, yeah. So that's going to help with the cooking time. Smaller pieces take less time to cook. I like that one. Cut up the vegetables at the start or buy pre-cut veg. Yeah, them frozen bags that you get in the freezer, frozen veg, like game changer. Very good. Vegetables don't have to be cooked all the way through. Better eating raw. Well, that's a matter of opinion. Depends what you're eating. I think I don't know. Let's put that to the chat. What are we thinking? Raw vegetables. Um, what am I? I'm imagining eating a raw carrot as part of a fajita. I think I'm okay with that. But I like the suggestion. Wow, I'm really impressed with like the creativity of how we can do this. I really didn't come up with a lot of these. I'm really impressed. Oh, thank you very much for joining. And thanks for participating as well. I've noticed your name popping up a lot. So is anyone, where are we on being finished or needing more time? It's difficult because I'm not in the room. People feeling ready to share their answers, or maybe how long they've got their process down to. Cut the chicken small and fry the vegetables together. Yes, very good. I like that one. Also saves them washing up, which I'm always a fan of. Oh, 24 minutes. Very good. Let's see. Let's make it competitive. I can't offer anyone a prize here. It's just for fun. But can anyone go further down from 24? Oh, we have a 22. We have a 22. Oh, down to 12. Not sure they'd be cooked though. Ah, would love to hear how they've got to 12. That's very good. Feel like a microwave might be involved in that one. Didn't say I couldn't. lots of prep post-cooking work, which is a good thing. Yeah, exactly. If you can externalize lots of your activities, you're going to save yourself a lot of time. Anyone else done any wacky things to help speed up the process? Anyone introduced any, like we talked about microwave, any different equipment? I've done this in the past and someone suggested using a flamethrower to cook the chicken. I don't know if that's safe, but way to be creative.
I think the 12 minutes is amazing.
Very good. Have you given it a go?
I'm working on it. I've
you?
got to about 28 minutes, which is, well, a lot of the schools are beating us.
Yeah. Have a look at some of the suggestions. They're pretty good.
Not sure about the raw veg though.
No, I think I'm with you on that. I don't think I can commit to that. Use a dishwasher. Boom. Yes. Very good. Get in some new equipment. So that's a classic example of an engineer bringing a piece of kit to help production out. Yeah, great suggestion. Fry the chicken and vegetables together. Yeah, yeah. Little stir fry going on. Very good. We're going to say 2 minutes on this so we have enough time for questions and wrapping up. No pun intended. Oh, yes, I will talk louder. Thank you. I was just saying we've got another 2 minutes on this and then we'll move on. High quality frying pans, get them T-fouls out. Yes. So any last numbers coming in, even if you've not got it lower than 12, let's just see what your class has done the best. How long have you got your process down to? Down to 32 minutes. Nice work. So you're basically saving the restaurant some time there, so they'll be pretty happy with that. Think of the customers getting their food that much earlier. It's going to make you happy. Okay, so thanks everyone for doing that exercise. I love this. I think they're really creative. So the thing with engineering is you'll never really know if you've got a correct answer. There will be lots of answers and all are correct and all are improvements. It's just selecting like which one is the best and which one's going to give you the greatest improvement. So really well done if you even managed to get that time down at all. All those are going to help the situation. And I guess the reason why I've given you an exercise like this is to just show you how easy it is to apply engineering to any situation, and how you already have instinct on what to do. So a lot of you straight away said like cut up the chicken, use pre-cooked veg. If you understand your process and if you understand the problem, it's really easy to then come up with a solution. It doesn't have to be rocket science. It can be so basically cooking, something that some of you might do a lot and know a lot about. Um, Once you understand the process, it's easy to kind of pick out, oh well, we don't need to do that, we don't need to do that, oh, you know, we could do that together. Something that wasn't suggested, I don't know if anyone came up with, but you could actually get another person to help out. So if you had two people working on it, you could get it done even faster. So there's lots of ways that you can improve things, and this is so transferable into engineering. So if I think about projects that I've worked on, exactly the same process. We want to go from one product to another. We took out all the things that we didn't need to do, all the paperwork that just doesn't need to be filled out, randomly, clearing up places that didn't need to be perfectly clean, um, and then externalizing activities, so filling out paperwork after we'd done the changes, getting the engineers to come in and fix parts of the machines when we needed them whilst we were running, if we could. And then finally streamlining activities. So during a changeover, we'd made sure that every operator was down on that line to get it done faster. And then we kind of like staggered their breaks whilst we were running because we didn't need them. So the tasks that need the most amount of time and energy, make sure that you've got people aligned to them. So that's kind of the whole reason of this. Also, I like making chicken fajitas, so that's there as well. If we go on to the last slide, please. So just some final thoughts for the session. So manufacturing engineering, I hope I've showed you it's everywhere, and it's a diverse and exciting career. You can literally go into any field and there is engineering. Take your hobby if it's sport, or if you like space and astronomy, you can go into aeronautical engineering. If you like cars, if you like boats, if you like clothes, fashion, there is engineering literally everywhere. So that example that we just did about complex problems can be resolved really easily by breaking them down into simple concepts. So if you have something that's a big problem, break it down to something that you understand and is nice and straightforward, and then you can start to break it down even further and start resolving things with easy day-to-day techniques. And then just to repeat what we said at the start, but I think it's some good life experiences, just be present. So whatever you're doing, make sure that you're there, you're listening, you're engaging, like make the most of the opportunities that you get and seek out new ones. Be curious, keep asking questions, ask why things are going the way that they are, because that's the only way things change. And be heard. You guys all have your own voices, and it's more important than ever to make sure that those are heard for whatever reason. So thank you again, and if we have any other questions, be more than happy to answer them.
Alicia, thank you so much. I think, I found you so inspiring, and I'm sure the young people in the schools did as well. I think that you had some great questions as well, and it was just lovely to have that task at the end to really focus us on what engineering is, and just to give a little snippet really of what it can be, because like you said at the beginning, we are not always sure what it is, and young people always say, what does it actually mean? Are you building stuff? Are you designing things? And you really, made it so informative and interesting. And James, he's just said, one of the teachers, they're in a girls' school, and really appreciate the opportunity to hear from women in careers dominated by men. I couldn't agree more. Thank you so much for your time. Thank you to the schools who joined us today as well. Vanessa has recorded this session and she will be making it available for you. I know a few of the classes joined a bit later, but don't worry, you will be able to see the whole session. And I think I encourage you to watch it. It is really interesting, and I encourage you to also share it with other classes as well. And Alicia, we wish you all the best. Thank you so much, especially with the vaccine at GSK. I hope that comes through and you produce your billion. So thank you very, very much to everybody.
Yeah, thanks again, everyone.